Okay. This time we will be dealing with a tree reservoir problem in which the flow is not identified or hindi specified sa problem. So, ang tanging kaibahan niya dun sa problem na identified yung flow dito sa hindi identified yung flow is that yun lang, yung direction of flow lang, hindi siya unknown siya. So kailangan lang natin siya i-determine gamit ang ilang assumptions na provided din naman dito sa book kung paano dinerive, and then i-explain ko rin naman kung paano siya kinuha. Sa page 412 to 402. So andyan siya. Anyways, here. So ito sabi sa problem, determine the flow into or out of each reservoir in the pipe system shown. Use coefficient of roughness 0.011 for all pipe. So given si N, ang gagamitin natin na formula dito ay syempre yung mga formula ni Manning equation for pipe friction losses. Yan. Okay. So sa ganitong types ng problem, meron tayong kailangan assumption na gawin para ma-identify yung flow. Dahil pag na-identify natin yung flow or yung direction of flow, madali na siyang i-solve, katulad na lang siya nung na-solve natin previously. Okay, so let's try. Ano yung unang assumption natin kailangan gawin? Is mag-identify tayo ng isang reservoir kung saan sasabihin natin na hindi nagfo-flow yung tubig. Assume natin ngayon that ang pinakamaganda dito is usually yung nasa gitna na reservoir yung inaan natin, pero kahit ano naman madali natin ma-identify yun. Pero for this example, try natin sa gitna. Itong si reservoir B. Kasi ABC yan, ABC. Reservoir B hindi daw nagpo-flow. So ibig sabihin, yung Q dito is 0. Assume at B Q is equal to 0 or HF2 is equal to 0. Andyan siya. Pero walang flow, walang head loss dahil nga hindi gumagalaw yung tubig. Okay. So kapag ganun yung sitwasyon, 'di ba, parang siya? Parang nangyayari dito, nagkakaroon tayo ng piezometer sa gitna, no? Parang imaginary na piezometer. Then na-determine natin na yung level ng tubig is ayun din. Yan. Tama. Kung ito yung piezometer natin, itong pula, tapos yung tubig natin hanggang dito lang. Kapantay ng current na elevation ng tubig. So, sinasabi na yung pressure at this junction, can still push, or the energy at this point can still push the water up to the piezometer, up to this level, elevation 24. No? So ano ang nag-cause, bakit hindi sila nagpantay-pantay? So possible, ang nag-cause dyan is yung natawag natin mga head losses. So parang nangyayari dito, from point A, from reservoir A down to this junction, nagkaroon tayo ng head loss na equivalent sa nawawalang ito. Tama? So pwede natin siyang equate sa HF1. Then ganun din ito. Ganun din itong si reservoir C. So, kapag ganun yung assumption natin, makakasolve tayo ng HF1, small letter, HF1 na equal sa 30 minus 24 equals to 6 meters. Then HF2 na 24 minus 15, which is equal to 9 meters. Okay? Hindi pa ito yung tunay na head losses. No? Kasi, ano lang to, merong assumption pa lang natin ito. Kung hindi nagpo-flow yung tubig dito sa second na reservoir. So, ano gagawin natin? Meron tayong HF1 at HF2. Mako-compute natin gamit yung Manning equation for frictional losses na HF is equal to 10.3 n squared LQ squared over D raised to 16 over 3. So, meron tayong L, meron tayong D, meron tayong N, meron tayong HF na assume. Ibig sabihin, masasolve natin si Q. Masasolve natin ngayon yung dalawang Q, si Q1 at si Q2. So, gawin natin. So, HF1 is equal to 6 meters is equal to 10.3. N is 0.011 square. Then, L is 1,200 meters. Q1, yung inassume natin na Q1, then i-square natin siya. Then yung D is 0.3 meters, 0.3 meters. Raised to 16 over 3. So, masasolve natin si Q1 as 6 times 0.3 raised to 16 over 3 over 10.3 times 0.011 squared times 1,200. That will give us a Q squared of 6.52. Kunin natin yung square, that will give us 0.08078 cubic meter per second. Store ko siya sa A. Wala lang, store ko lang siya sa A. Hindi, insignificant pa to. Hindi pa ito yung tunay na value ng Q1. Magagamitin lang natin siya to identify the flow. So, si Q2 naman, HF2 is equal to 9 meters. Is equal to 10.3 times 0.011 squared times length is 1,500 meters. LQ2 squared, diameter is 0.15 meters raised to 16 over 3. So we will just use the same papalitan na lang natin. So that will give us 0.15, ito ay 9 times 0.15 raised to 16 over 3 over 10.3 times 0.011 squared times the length of 1,500. Then, pag i-square root natin yan, makukuha natin Q2 is equal to 0.013994 cubic meter per second. Bigyan nyo sabi. Gusto ko lang siyang masave. Okay. Anong makapansin nyo ngayon kay Q1 at kay Q2? Mapansin natin na si Q1 Q3 pala ito. Q3, sorry. Ano man sabi natin kay Q1 at kay Q3? HF3 to, sorry. Yan. HF3. Ano man sasabi nyo ngayon kay Q1 at Q3? Sa values nila. So, ang makikita natin na si value ng Q1 is greater than Q3. Tama? Ibig sabihin, yung direction ng flow natin, kapag ganyan yung sitwasyon, is that from reservoir A, From reservoir, ibababa yung tubig. Ito yung Q1. And then, since maliit yung value ni Q3 sa kanya, ibig sabihin, yung the rest ng flow from Q1 will be going to Q2. Yan. So, ibig sabihin, yung flow sa Q3 is ganyan, and then yung flow ng Q2 is pa ganyan. Yan. Okay? So, yun yung naging basehan natin. So, paano kapag baligtad yung nangyari? Halimbawa, lumabas na si Q3 is less than Q1. Ano mangyayari? Ano mangyayari kapag bumaliktad yung sign? Halimbawa, maging Q3 is greater than Q1. Ibig sabihin, yung flow, kung mas malaki si Q3, ang mangyayari sa kanya, si Q3 ay papunta doon, ibig sabihin nun, kapag mas malaki pa si Q3, ang assumption natin is si Q1 is pababa, pag ganun. Ang mangyayari is si Q3 pag ganun pa din, pero si direction ng Q2 will be the opposite. Opposite nito, no? Pababa. Ibig sabihin, yung flow from Q1 and yung flow from Q2 is going kay Q3 kasi nga siya yung pinakamalaki. Okay? So, ganun yung nangyayari sa ganitong problem. So, tanggalin na natin to kasi hindi naman yan mga tama. Okay? So, alam na natin yung direction ng flow. Pwede na natin ma-solve yung flow ng sa bawat pipe system. Pati yung mga tunay na head losses in them. Okay. So, alam na natin that Q1 is equal to Q2 plus Q3. Okay? So, itong red na piezometer na to, hindi na natin to iisipin dahil alam na natin yung mga flow. Hindi na ganyan yung tunay na sitwasyon. Okay? So, pagdating ng Q1 is equal to Q2 plus Q3. So, pwede tayong kuha muna tayo ng equation, Bernoulli energy equation from point A to point C. Okay. So, we will have VA squared over 2G plus PA over gamma plus ZA minus HF1 minus HF3 is equal to VB squared over 2G plus PB over gamma plus C pala ito, C. Yan. Yan. So, alam naman natin ulit tayo, ito ay negligible. Ito ay 0. ZA is 30 meters above elevation 0. Assume natin as D2. Then, HF1, masosolve natin later. Then, ito is negligible. Then, this is 0. Then, this is ZC. ZC is equal to 15 meters. So, ang natitira, HF1 plus HF3 is equal to 30 minus 15 meters. Isang working equation. Punta na naman tayo kay A to B. So, copyin na lang natin ito, si HF3 maano. So, sige na nga, sulit na natin. VA squared over 2G plus PA over gamma plus ZA minus HF1 minus HF2 is equal to VB squared over 2G plus PB over gamma plus ZB. Ang matitira dito, as we all know, is 30 minus HF1 minus HF2 is equal to negligible 0. The GB is equal to 24 meters. Okay? So, pag sinimplify pa natin, HF1 plus HF2 is equal to 6 meters. Okay, so meron tayong equation 1, then meron tayong equation 2. No? Equation 2. Okay. So, paano natin ngayon isa-solve C, Q ng bawat isa? So, gamit itong dalawa natin na equation, makakakuha tayo ng gamit yung formula ni Manning. Ito, yung 10.3 n squared LQ squared over d raised to 16. Meron tayong L, meron tayong D, meron tayong N. Q lang yung nawawala. So, pwede natin gamitin ngayon to solve, to arrive at an equation in which Q2 and Q3 and Q3 is expressed as Q1. So, kapag nakuha natin yon, meron tayong Q2 in terms of Q1, Q3 in terms of Q1. Then, isa na lang yung ating unknown, no? Which is Q1. That na masosolve na natin. And then, eventually, masosolve na natin lahat after that. So, dito tayo sa taas. Yan. So, doon muna tayo sa HF1. HF1 in terms of Q1. HF1 is equal to 10.30 n squared L1 Q1 squared over D1 raised to 16 over 3. So, substitute the values, 10.3 and 0.011 squared. Tapos, L1 is 1,200 meters. Q1 is unknown. And then D1 is 0.3 meters raised to 16 over 3. Then that will be our HF1. So, simplify natin para shorter yung values na input natin mamaya. So, 10.3 times 0.011 squared times 1,200 over 0.3 raised to 16 over 3. That gives us 919.3703 Q1 squared. So, meron tayo sa equation. Store natin to sa yung numerical coefficient. Then, ganoon din gagawin natin kay HF2. .30 n squared L2Q2 squared over D2 raised to 16 over 3 HF2. Bibilisan ko na lang yung pag-compute. Papalitan ko na lang yung values dito. Yung L2 is 900 meters. 900 meters, and then D1 is 20 centimeters. Yan, is 16 over 3 pa rin. Then the numerical coefficient is 5993.839 Q2 squared. And then HF3 is equal to 10.3 n squared L3 Q3 squared over D3 raised to 16 over 3. That gives us HF3 equal to, ganun na lang ulit, that is, in diameter is 15 Then yung length is 1,500. The numerical coefficient is quite large. 1,500.15. Okay. 46,333.3611 Q3 squared. Store natin siya sa C. Store ba natin yung kanina sa B? Yan, ito siya na-store sa B. So, this will be B. This will be stored sa C. Okay, since nakuha na natin yung nakuha na natin yung HF1, HF2, and HF3 in terms of Q1. Okay, since nakuha na natin yung HF1, HF2, and HF3 in terms of Q1, Q2, and Q3, pwede natin silang gamitin to solve yung value ng ating Q1 so paano natin gagawin yun? So una, kailangan natin yun nga, nabanggit natin kanina to na HF1 gamit yung equation 1, HF1 plus HF2 HF3 is equal to 15. So, sa substitute lang natin, we will have a 919.3703 Q1 squared plus HF3 in terms of Q1 4633.3611 Q3 squared is equal to 15. So we can have a Q3 in terms of Q1. We will have, so tago na lang natin ito sa pangalang C, and then ito sa pangalang A para mas maikli yung pagsusulat natin. And then Q3 squared na lang muna para simple yung sulat. We will get Q3 squared is equal to 15 minus AQ1 squared. AQ1 squared over C. Okay? And then, ganun din gagawin natin sa kabila. HF1 plus HF2 is equal to 6 meters. We will have AQ1 squared plus, ang gagamitin naman natin dito is yung B na 599.3.839 Q2. So B Q2 squared is equal to 6 meters. We will get Q2 squared is equal to 6 minus AQ1 squared over B. Then, gagamitin na natin si Q1 is equal to Q2 plus Q3. We will have Q1 is equal to square root of Q2 6 minus A Q1 squared over B plus square root of 15 minus A Q1 squared over B over C. Yan ang value ng ating Q1. Now, yung mga ganitong klase ng equation is mahirap itong solve. Hindi pwede kang gumamit ng mga iteration method to solve this. Pero yun, i-prefer lang natin siya gamit ng ating calculator. Okay. So, Q1 is equal to, so parang Q1 is equal to X is equal to square root of 6 alpha A 6 6 minus alpha is 6 alpha A alpha x squared over alpha B plus square root of 15 minus alpha A alpha x squared over alpha C. We will get Q1 is equal to 0.043559 cubic meter per second, or Q1 is equal to times 1000 43.5598 liters per second. Divide ko sa 1000 para isi-save ko siya as alpha F. As alpha F. Ayan. So meron na tayong Q1, mas-solve natin si Q2 and Q3 very easily kasi meron na tayong ito. No, kung may Q1 na tayo, mas-solve natin si Q2 and Q3. So Q3 is equal to 15 Q3 squared 15 A Q1 squared over C. So that will give us square root of 15 minus alpha A alpha F squared over C. That gives us 0.016914 cubic meter per second, or 16.9142 liters per second Q3. So sagot din yan. Sagot din pala ito. Then Q2 can be solved by, pwede mo itong gamitin or pwede mong gamitin yung ito. So gamitin na lang natin yung 6 minus A Q1 squared over B Q2 is equal to 6 alpha B 0.02664 cubic meter per second, or Q2 is equal to 26.645 liters per second. So parehas ang sagot. Ayan. So pag dinouble check mo, dapat pag inad mo itong dalawa na to will be equal to this one. So plus 0.0169142. So approximately the same. Round off lang kasi tayo. Yan. Yan. So ganun lang siya i-solve, no? Medyo may involvement lang ng complicated na mathematics. Pero yun, madali lang naman yun. Madali lang din naman yun, lalo na yung iteration dahil paulit-ulit siya. So I know you can learn naman yung iteration on your own. Maybe you can use bisection method to solve this. Yun ang pinakamadali. Medyo rigorous lang yung process pero dali lang naman siya.